The difference between accuracy and precision can be confusing.
These last points, too accurate for sand people. Only Imperial stormtroopers are so precise.
2,228.7 to 1. Those are pretty good odds, Mr. Spock.
And they are, of course, accurate, Captain.
Of course.
What do you think accuracy is, and what do you think precision is?
Well, I don't know that I could differentiate them for you.
I shouldn't have to put up with this. I'm a precision instrument of speed and aerodynamics.
You hurt your what?
I went over to MIT, where students happened to be celebrating Hindu Holi, and gathered some very colorful opinions.
Besides that, I guess the method of reaching that information is like precise.
Okay, so if it's accurate, it's accurate, and if it's precise,
Correct.
okay.
Like how close it is to a particular value.
Okay. So what's the difference between correctness and exactness?
I'm measuring to say the exact opposite.
You know, okay, I got it. Okay, so accuracy is if you're playing the game with information, how accuracy is to put it in the actual spot. But precision is like if you get it near enough that it buzzes, but like it's still not the right time. If that makes sense.
And then I cross-checked at Harvard.
Or to be precise.
It depends on the first date or not.
Yeah.
First day, you want to be accurate. I feel like all this is accuracy on the first day.
Yeah, you should be accuracy to look good, but precise for the convenience of both people.
Yeah.
For instance, yes.
Precision would probably be
Alright.
important. Like
Yeah.
once you're comfortable with each other. But like you also like it's
But, like,
better to like
precise is bad if like you both decide to bail without telling the other person, but you just happen to be at the same restaurant. That's bad. You don't like that.
that's,
So then accuracy is
that's
better.
actually such a good point.
Right.
I asked a former alumnus of MIT for his opinion.
If you could give me from the mouth of the Smoot, what do you think?
Accuracy. Usually you hear as to the n decimal places, right?
Mhm.
How accurate this measurement is. But how is that different from precision?
Others share the confusion of the role of decimal places and accuracy and precision.
Not getting out of here.
Difficult to be precise, Captain. I should say approximately 7,824.7 to 1.
Difficult to be precise. 7,824 to 1.
7,824.7 to 1.
That's a pretty close approximation.
I endeavor to be accurate.
You do quite well.
And maybe, and you can tell me if I'm wrong, or at least I'm wildly off base, because then I'll have to change my script for my students. I tell them that accuracy is how close is a measurement to an established value for something.
How could you be sure that's accurate?
Because a split second before the torque wrench was applied to the faucet handle, it had been calibrated to be dead on balls accurate.
Dead on, balls accurate?
It's an industry term.
Whereas precision is a measure of how confident are you of your measurement because you've done it repeatedly or somehow recorded multiple measurements, and they all agree to within a certain decimal place.
Well, now I've learned something today.
I'm flattered. I hope I'm right.
There is one analogy that has proven useful for many students.
I got it. You know, in football, when they kick it into the big field goal area. So accuracy is getting it through and getting the points every single time. Precision is like how close, like the same direction that you hit every single time. So is it like, even if you miss, are you still putting it in the same place every time, kicking it in the right place every time?
So I actually play some darts. And so my understanding when I think about it from that sense is accuracy is hitting where you want the dart to go. And precision is, you know, you might try to aim for a bullseye, but you go all the way to the right. But if you throw two more darts and they all go to the same spot to the right, that's precision, but not necessarily accuracy because you're aiming for the bullseye. So
Okay.
that's how I like to think about it.
Accuracy is like how close you are to like the ground truth. And precision is how big the variance between the range of accuracy is.
Right.
Moving on. So here's the demonstration of accuracy. Not very accurate at first. Much more accurate. Meanwhile, to demonstrate precision, we can have not another archery demonstration. Sorry.
Thank you.
But instead we can use, if you listen carefully, the drummers who are all in sync. Their precision is very high. The other point that was being made is it's entirely possible to be precise and yet completely inaccurate.
Yeah, it's 8 o'clock.
Perfect. My experiment worked. They're all exactly 25 minutes slow.
Wait a minute, Doc. Are you telling me that it's 8:25?
Precisely.
One of the favorite topics for physics teachers is to use the Harvard Bridge, or the Smoot Bridge, named after Oliver Smoot, who was destined to become a fixture of units and measurement.
For the sake of viewers who are not familiar with the Smoot, this is Dr. Oliver Smoot, sometimes known as Ollie Smoot, and is the famous progenitor of the Smoot, which I'm going to be asking him to tell us more about. I was just curious. I remember from Ferris Bueller's Day Off, there's a lovely scene with an economics professor who was going on and on about the Smoot-Hawley Act.
The Hawley-Smoot Tariff Act, which anyone raised or lowered.
Are you by any chance related?
Yes.
And you appear to be also a distant relative of George Smoot, winner of a Nobel
Yes,
Prize.
we're cousins. When he was being interviewed on NPR after he and his co-Nobelist were awarded the prize, at the end of the interview, they opened the line for questions, and the very first question was, "George, are you related to the Smoot?" And I think he was taken aback. And supposedly all of the Smoots came to the U.S. in one ship in the 16-somethings. And
I asked Dr. Smoot to explain the history of how he became a part of history.
Explain what we're seeing here.
Well, as freshmen, all of the guys pictured there, they were my pledge brothers at Lambda Chi Alpha fraternity at MIT.
Okay.
And in October, at one of our regular Wednesday night pledge training classes, our pledge master, Tom O'Connor, said, I have a hard time knowing when I'm going to get to MIT because we lived in a house in Back Bay, Boston, and you got to MIT by walking across a half-mile long bridge. So he said, go out and measure the bridge, and there were 14 pledges, and I was the shortest. So he chose me to make it the most work, I guess. So the next night we set off, as you can see, with some chalk and some paint, and Gordon Mann has a clipboard in his hand, and we started measuring. So this is what happened later. I could do push-ups and stand up, maybe for 50 Smoots, and then I had to have help. I'm not sure this one was help.
So they didn't do this for the entire length?
No, and no rolling over like a lot of people think. I don't know how anybody thinks that would have been very efficient. One of the things that happened is, I don't know, halfway across, a sophomore in our house, who later became a minister, was coming from MIT, and he did a U-turn and came over to see what we were doing because he could see he knew some of us, and he decided to join us. So after that, we really had to play it by the book because here was a sophomore, an upperclassman monitoring us. So, so that's Pete Miller, who lives in Lexington, and Gordon Mann, who lives in Ohio.
Very good.
And as you can see, they're helping me.
Yes, that does seem pretty helpful right there.
And was I ever glad I wore gloves? It wasn't really cold, as you can see, but you can also see how rough the concrete is.
Mm-hmm.
I think by the end of this, those gloves were pretty much done for. Or I frankly don't remember toward the end what we did. It just, it's just lost.
So the other item that I wanted to ask you about is, as you said, there were 364.4 smoots, give or take an ear. Why only 364.4 smoots, no more decimals, and the significance of plus or minus 1 ear?
So what I've been told is that it didn't say plus or minus. And so it said plus. And the E of ear was an epsilon, because one of us said, oh, epsilon denotes an error measurement, and so let's be cute and make it that.
So that's how it became evolved into plus or minus 1 ear.
Yeah.
Okay.
Because otherwise your point is perfectly valid. Why not make it 0.44 or whatever?
So I wanted to get your thoughts on measuring the importance, the significance of significant figures, uncertainty, and what the value of increased precision has for us in science.
So I guess, amazing thing to me was when the bridge was rebuilt in 1987, the fraternity went out and they did use string and they measured all of the marks, only to find out that some decades were 9 lengths long and some were 11. To your point also is, how good was our methodology in marking each body length? Because if you had, I think Pete Miller was the one always with the chalk, if he was sort of loose about where the top of my head was, you're going to have a cumulative error all the way across 364.4 smooths.
Indeed.
Yeah. Then the biggest, this is maybe your students would appreciate this about assumptions. We started at the expansion joint where the bridge begins to go over the water of the Charles River. So in the rebuilding, the project engineer got on board with the smooths, but he said we made a huge mistake because the bridge itself begins on the east side of Storrow Drive. So that's maybe a good 100 feet further on the bridge than we measured. So, your going in assumptions have a pretty important impact on your outcome too.
Very. But in terms of real life engineering, science in particular, what to you is the significance of significant figures? What does it mean to you? And what does plus or minus, the uncertainty of a measurement, mean to you?
I think significant digits, well, actually, they amaze me. There are certain things like Avogadro's constant, but you always see like 20 digits, but it's a very small number. I mean, how did they ever do this?
So the way I tell my students is, I have different rulers with different markings on them. So, I have a meter stick, which is just a meter, and then I have a meter stick which has decimeters on it, and centimeters, the usual, millimeters. And ask them, so these are all meter sticks. Are they all equally accurate?
Yep.
Are they all equally precise?
Right.
Which side would you say is the most accurate, and which side is the most precise? Feel free to pass it around.
This is like the concept of decimal.
I would say precise because you have all the millimeters. Precise? Accurate,
I think accurate, they're all accurate. But I feel like this is more precise. I don't know.
Aren't they all the same accuracy? And then this would be the most precise?
Okay, what's your reasoning for those two answers?
I
I mean, unless there's some weird, I'm pretty sure they're all every side is the same length, and within like, in this size little chips. But yeah, I would say they're pretty much all the same length, and then they're all the same accuracy. And then this is the most precise as it goes down to, there are these centimeters, millimeters.
Okay.
This is
That is a good answer.
Let's go.
Josh!
See?
Great job, Dad. You did awesome.
All right. But it's interesting because a lot of people have difficulty going from the dartboard analogy to an actual measuring instrument, which has nothing to do with darts or scoring a basket or whatever.
The confusion arises whether significant digits are meaningful for accuracy or precision.
So, for instance, in the case of where to meet, if you're going to meet at the movie theater, does it matter whether you meet on the sidewalk right in front of the movie theater, slightly off to the side by the ticket counter? Do those things really matter?
No.
So you're arguing for precise here.
Yeah, that's what
Actually,
it sounds
It's annoying if you're like, I gotta be
like.
accurate.
Those things matter.
No, that's an argument for accuracy. You're at the theater, and they can find you, but whether you're here or here doesn't really matter.
Well, that's true. Kind of, but that's also like saying, oh, hitting the dartboard is hitting the dartboard, but hitting different places on the dartboard is still can change it.
And yet you correctly said which one of these was the most precise. You see how this works?
Yeah.
You correctly chose the one with the smallest increments. But in the case of a date, for instance, precision is not really the determining factor because you don't care to the nearest millimeter, for instance, where they're standing. Having to go to a birthday party, is it more important for the birthday party invitation to be accurate or precise? Well, it's all the different ways that accuracy and precision pop up in our daily lives. And so that's one of them.
Talking about the time or also the address, or
Why not both? We live in space-time, so is it important for the time to be accurate or precise?
Accurate.
All right. Why do you say?
Because, for example, you can be precise in the time of arrival, but if you arrive 5 minutes late or 5 minutes before the time, it's not very important. It needs to be accurate in order for people to know.
Whether you show up at the start of the movie or just say 2 seconds later.
You want to be as late as possible in those movies. They run ads for like 20 minutes.
Most blokes are going to be playing at 10. You're on 10 here, all the way up, all the way up, all the way up. You're on 10 on your guitar. Where can you go from there? Where?
I don't know.
Nowhere, exactly. What we do is if we need that extra push over the cliff, you know what we do?
Put it up to 11.
11, exactly. One louder.
Why don't you just make 10 louder and make 10 be the top number and make that a little louder?
These go to 11.
In fact, one of the things I plan on doing is going out to the bridge with my own measuring tools, and similarly to how I challenge my students in class, ask people to guess and measure how many feet there are in a smoot. And then, of course, depending on what kind of foot I give them or what kind of size feet they have themselves, the answer will, of course, change quite a lot.
Right.
But if I standardize everybody's units, they should all coalesce toward a certain number, even if the original data is wildly different.
So we're going to play with the data right now and stick it in my lab. Here's a sample of the kind of work that I have my students do. You can see my basic layout, so let's hit it. And there we go. Notice how the average, even if it's correct, goes on indefinitely. Again, a good talking point, whether you want to be rounding this or not. So, carrying on, we now have part 2, where we have to stick in our conversion data. The precision for the so-called feet are all over the place. This would not be very good data. Whereas the precision is pretty good for the same measurements, converted to centimeters now. Now looking at the accuracy of the average of the measurements compared to the accepted value, the feet are not particularly accurate. Whereas for the centimeters, the accuracy is again pretty darn good, under 5%. There are, of course, many real-life examples of this. For instance, due to human error, this was the last view that the Mars Climate Orbiter had on its final approach.
Tonight that a multi-million-dollar spacecraft sent to explore the atmosphere of the planet Mars has been destroyed. It's a setback to years of work already done. In the vastness of space, all it takes is one navigation error. In this case, NASA was off by 60 miles.
A textbook case of why stating units is important. Space also has excellent examples of the value of precision. Or Oliver Smoot's Nobel Prize-winning cousin, whose work on the cosmic background explorer was succeeded by the increased precision of the Wilkinson microwave anisotropy probe, which was still further improved by the increased precision of the Planck Observatory. Detecting the ripples in space-time took 25 years because of the precision required to detect waves that small. How small? Precise enough to measure the movement of 1/1000th of the diameter of an atomic nucleus. That level of precision will allow you to hear the chirp of two merging black holes halfway across the universe. Thank you for watching. Please press the subscribe button and like my video, and hit the bell for more alerts. Please leave a comment, and if you go to my Patreon page, you can see all the different extras and goodies that are available. Thank you.
Yep, it's a good one.
That sounds like a song.
Okay, that sounds
Alright.
good. So we're average.
Yeah, we
we're
got
like
this.
we're so. Thanks for saying that.
We
Everybody,
really appreciate
I
it.
thought I was doing really well there for a second. Okay.
Finally,